Hello students, in the last class we learned about the connection between the turbine rotor blades and the wheel disc. Today, we will learn about the stator components of the turbine. The turbine stator is composed of the turbine case guide and the turbine ons, support, and force transmission components. Let's first understand the turbine case. The turbine casing is generally a cylindrical or conical thin-walled shell. The turbine casing has the following functions. First, it fixes the guide. Second, it connects the combustion chamber, and the nozzle transfers the load of adjacent components and transfers torque, axial force, inertia force, and internal and external pressure difference. Third, it directly or indirectly forms the wall of the gas channel, improving the efficiency of the turbine. In the design of turbine casing structure, it has become more prominent to ensure that the turbine casing maintains sufficient rigidity at high temperature, avoids distortion and deformation, and maintains a reasonable radial clearance between the casing and the rotor. Therefore, the design of the turbine casing should meet the following requirements. First, the radial clearance of the turbine blade tip should be reduced as much as possible to improve the turbine efficiency, but the rotor and stator should not be damaged during operation. Second, the casing should be sufficiently rigid, the weight of the casing should be reduced, and it should be easy to assemble. Third, during operation, the casings should be able to be well thermally centered with each other, and the rotor and stator should maintain good concentricity. Based on the above design requirements, and in order to ensure that the radial clearance of the turbine is evenly distributed along the circumference, the turbine casing must not only have a certain rigidity, but also be relatively uniform along the circumference. Therefore, the casing is usually made into a full ring. That is, it is generally made into an integral casing or a segmented casing. The use of a transverse joint surface will make the circumferential rigidity of the receiver more uniform, and the mounting edge will also serve to enhance the transverse rigidity. Next, let's learn about the connection between the turbine guide vane and the casing. The turbine guide vane is an annular, stationary blade grid consisting of an inner ring, an outer ring, and a group of guide blades. For the impact reaction turbine guide vane, due to the convergence of its blade channel, when the gas passes through the convergent channel of the guide vane, the speed increases, the pressure and temperature decrease, and the airflow direction also changes. Therefore, the function of the guide vane is to convert part of the heat energy of the airflow into kinetic energy and flow out in a certain direction to drive the impeller to do work. Although the turbine guide vane is a stationary part, its working conditions are very harsh. In addition to being subjected to large aerodynamic forces and unstable pulsating loads, the guide vanes are also surrounded by high-temperature combustion gas, with high temperature, large changes in temperature, and uneven temperature, which has the greatest impact on the first stage guide. In view of these working characteristics, the connection design of the guide meets the following requirements. First, when working at high temperature, the guide should have sufficient strength and rigidity. Second, the thermal stress in the guide should be reduced. Third, the guide vanes are not load-bearing parts. If the inner and outer rings need to transmit force, special load-bearing parts are usually required. Fourth, the guide vanes are made into a single or a group of 2 or 3 blades, which is convenient for installation, positioning, and tolerance control. For the turbine stage, I guide vane at the combustion chamber outlet, the operating temperature is the highest and the temperature is the most uneven, so effective cooling measures are usually adopted. In order to ensure that the blade has sufficient rigidity, a double pivot structure is adopted with both ends connected to the casing. As shown in the figure, this is the first stage turbine guide vane of the WP6 engine. The first stage turbine guide vane of the WP6 engine is hollow, with both ends freely inserted into the molded holes formed by the inner and outer pillows, leaving a gap in the radial direction so that the blades can expand freely after being heated. In order to transfer the load of the front support of the turbine, the inner and outer casings are connected into one by passing the tie rod and the liner through the inner cavity of the blade. The tie rod bears radial tension and is the main load-bearing member. The liner is compressed to ensure the concentricity of the inner and outer casings and plays a role in determining the distance. The guide vanes of the second stage and subsequent stages of the turbine are located between the two stages of working impellers, so only a cantilever structure with a fixed outer end can be used. The load acting on the guide vanes is transmitted to the outer ring through the outer end of the vanes. Since the guide vanes of the latter stages are relatively long, in order to enhance the rigidity, the inner crowns of the vanes should be close to each other during operation and form an inner airflow channel. The operating temperature of the guide vanes of the latter stages is relatively low, so ventilation cooling is generally not required. As shown in the figure, the connection between the second stage guide and the casing of the MAQ-02 engine high-pressure turbine is an outer-end fixed cantilever structure. The second stage guide and the interstage sealing device are self-contained and then fixed on the inner crown of the blade. In this structural design, the sealing ring must be reliably centered and must not affect the free extension of the blade after heating. Students, in this class, we learned about the composition of the turbine stator components, the types of turbine casings, and the connection between the turbine guide and casing. Students must master the connection method between the turbine guide and casing after class, and complete the after-class self-test questions in time. Thank you, everyone.